Okay, so today we're going to be working through some of the proofs that are in your book from pages 66 to 69. Sorry, 65 to 69. The important part on page 65 is just kind of going over what we're usually going to be talking about with proofs, and that is the idea that in a given picture you're going to be given various information. It's also going to be written out. Again, the pictures are just there to help you organize the information. But you'll be given some information about a situation, and usually you will be asked to show that certain aspects of that situation are congruent or are equivalent. Okay, so the first one we're going to talk about is just that example from page 66. The information you're given is in the diagram, angle SPQ is equal to angle RPQ. So that's shown over here. Angle SPQ, that angle, is equivalent to RPQ over there. Okay? Oop, dear. Okay, there we go, sorry. And angle SPR is equivalent to RQS, these green parts. So we know that. So with that information, we need to find out why or how or if angles R and angle S are equivalent. With this information, the book states that the first thing you're going to want to do is probably redraw this diagram because they're overlapping, because we're really only concerned with this angle and this angle. And so we can get that information from two separate triangles, because right now we have triangle RPQ, we have triangle SPQ, we have, let's say we've got this part X, we've got triangle SPX, we've got triangle RXQ, we've got triangle PQX, and really none of that information is actually relevant. So what we're going to do is redraw this information, just showing the information that we need. Okay, so we have, again, triangle SPQ. That doesn't exactly look like that, but again, it's good enough for our purposes right now. Move this over a bit. We have triangle RPQ. So SPQ, RPQ. Okay, so now what we need to do, we know that this is equal to this. Going back to the reflexive property, we know that the PQ in triangle SPQ is the same PQ as the PQ in RPQ, so we've got this and this. So we're well on our way to either a side angle side or an angle side angle proof to show that these two triangles are congruent, because that's what we need to do. We need to show that the triangles themselves are congruent, because then if the triangles are congruent, any of the corresponding parts are also going to be congruent. And since we have P and Q, that same section in both of them, triangles S and R would then be congruent parts, or I'm sorry, complementary parts. Oh, sorry, cat on my lap. To these triangles. Okay. Sorry, cats. Okay, so we need to figure out how we can show that these are congruent triangles, and that's what we're working on. So we start with our proof. So we start by saying, we list the things that are given first. So 1, here again we have our statement, and our reasons are going to be over there. I'm not going to write that out because there's going to be too many R's and S's, but this is in your book so you can follow there as far as the statements and the reasons. So the first thing that I'm going to write, and you'll see I'm writing this in a slightly different order than the proof that's in your book. And again, that's okay. As I've said before, there are lots of different ways to go about geometric proofs. And again, as long as you're using legitimate postulates and theorems to back up your reasons, for your reasons, you can do it any way you want. Okay, so I like to start with the givens. They started with the reflexive property of equality. I'm going to start with the givens first. So we know that angle SPQ is equal to angle RPQ. And we know that because it's a given. They told us that. Helpful to have that information. We also know that angle SPR is equal to angle RQS. And we know that because they told us. Now, when we rewrote our pictures, when we redrew that diagram, we lost that angle, but it is still part of it. We still have, the line PR over here. So it is important if you're redrawing things to remember that it might not contain all the information that you need. Okay? And so then as I redrew this, the first thing I said was that, the PQ in triangle S is the same PQ as in triangle R because in our original diagram, it was the same line. So 3 PQ equals PQ. That seems like something that's pretty obvious, but it's definitely still something you want to write out, just to make sure that all of your bases are covered, especially when we're separating these two triangles in this different diagram. And then reflexive property of equality. All right, so now, given the fact that we have this large angle P and this large angle Q, now we are concerned with angles S and angles R. So we have we have an angle and a side. So we could go about this as an angle side angle proof. So we've got angle side angle. We could look for another angle, or we can go about this as a side angle side proof. Okay? Either one of those is fine. I guess it doesn't really matter too much. Okay, so now this next step that we're going to be looking at is we know that this area over here and this area over here is equivalent, but that doesn't really help our new diagram over here. So we need to use that information possibly to do something with these angles, because there isn't really any way to tell that any of our sides are equivalent. We don't have any kinds of numbers, anything like that, but we do know that angles are equivalent, so it seems logical to continue along the angle road. So we know that this big angle and the big angle P and big angle Q are equivalent. We know that from our original diagram in that triangle SP unknown intersection, that smaller part is equivalent to the smaller part of triangle RQ unknown intersection. So we have two equal large angles, and we have then two equal smaller angles. So that to me sounds like, well, if we look over here at this big diagram, we've got the green angle and the blue angle, and that equals the black angle. Again, the green angle and the blue angle equals the black angle. If we take those green angles over to our little the blue angles over to our little diagram, we get those skinny angles P and Q. All right, and we can do that because of the subtraction property of equality. So let's go back to black. Okay, okay, so we know that the big angles are equal because they told us that. That's what this says up here. We know that these smaller angles are equal. So then we know that angle RPQ is equal to angle SQP because of the subtraction property of equality. And actually, I am going to just write subtraction property of equality. Okay, so we know that those smaller, so we've got an angle, we've got a side, we've got an angle. We know that those are congruent. Okay, so now if we've got an angle and a side and an angle, now we know that the triangles are congruent. So triangle SPQ is congruent, the little squiggly line means it's congruent, is congruent to triangle RQP, again being careful of how we write those to make sure that the corresponding parts are, in the same order. And 5, that's because of angle, side, angle. And your book says specifically, it lists angle, side, angle due to the various steps. If that helps you keep it in your head, that's fine. I'm not going to require you to say which steps you proved that those are in because, it's in your proof. And then, so if our triangles are congruent, 6, angle S would then be equal to angle R because of corresponding parts. Corresponding parts. Lots of abbreviations, and that's fine. And as long as we're using the same abbreviations, that's okay. So yeah, if we're doing just the regular kind of arithmetic kind of things, we've got the addition property of equality, the subtraction property of equality, the multiplication property of equality, the division property of equality. You want to use those symbols, that's fine. If you want to write it out, by all means go ahead and write it out. Otherwise, you can abbreviate things, and that's fine too. All right, so now let's look at the next one. Okay, so we are told that this line XPOQY and AOB are straight lines. So 180 degrees going to be important there. Okay, so PO here equal to OQ, which is then why I have these lines there. Angle 1 over here is equal to angle 2. Good information to have there. Okay, and then prove that angle A is equal to angle B. So we're looking for that in the blue. All right, so now here is one of those ones where it doesn't look like you're given a lot of information, but you actually are. Okay, so since we have straight lines, okay, so we are going to say 1 XPOQY equals 180 degrees because that's a given. 2 AOB equals 180 degrees. I'm saying that instead of writing that it's a straight line. 2 given. 3 angles 1 equal angle 2 given. And just to make sure all of our given stuff is there right at the beginning, for PO equals OQ. It's a bad Q. That's a better Q. Given. Okay, so that's all of our given information. So now we start to look at this. All right, so we have a side that is equivalent because that's given. And then we have this situation over here. So we have two straight lines that are intersecting each other. All right, so now we haven't talked about that in this chapter, but we have talked about that. And sorry, I'm taking a second to look up what they're called. Haha. Okay, so they are on page 49. Angles formed by intersecting lines. When two straight lines intersect, four angles, each less than a straight angle, are formed. So we have two straight lines intersecting. These angles, numbered 1, 2, 3, and 4. Okay, so two adjacent angles can be seen as supplementary. So 1 and 2, you can see if we take angle 1 and angle 2, that gives us our straight line of XPOQY. It's a fun line to name all the time. And two opposite angles, such as 1 and 3, are equal. Now in this particular proof, we don't really care about angles 1 and 3, but we do care about angles 2 and 4. And we know that angles 2 and 4 are equal because if we have straight lines that are intersecting, they're going to be crossing, you know, at the same angle on both sides. So if angle 2 and angle 1 add up to 180 degrees, angle 2 and angle 3 add up to 180 degrees, angle 4 and angle 1 add up to 180 degrees, so therefore angle 4 and 3 add up to 180 degrees. Because of all that mishmashing, therefore, you know, we talked about, you worked on that on page 49, angles 4 and 2 are congruent. So in this book, it calls them opposite angles. When I learned it as vertical angles, so if I get those confused, I'm sorry. Okay, so let's not be in green anymore. Okay, so 5 angle. Now the 1, 2, 3, 4 is not actually in this problem, so we need to actually name the angle. BOQ is equal to angle AOP because they are not vertical angles, because that was opposite angles. Okay. Okay, so the definition of opposite angles tells us that those are equivalent. So now, okay, so we have an angle, we have a side, and then we have that information about angle 1 and angle 2 being equal. So if we look at just this section over here with OQY, we've got OQY over here, and we've got ray B coming up. We have over here 2. So then over here we're going to have, I don't know, angle OQB. But we know that since OQB is a straight line, we know that angle or since OQY is a straight line, we know that angle OQB is going to be the supplement of angle 2. So I'm just going to write S2, supplement of angle 2. So then if we also have angle XPO, and we've got ray A, and over here we've got 1, this is going to be the supplement of angle 1. So if two angles are equal, their supplements are going to be equal as well. So 6, we have angle BQO is equal to angle APO because they are supplements of angles 1 and 2. And so again, this is where it's really helpful to have all those postulates in your head, because I know that that's the reason. Now I need to look for a postulate that proves that. So just like you're going to be doing for the first couple of chapters, I am looking through my book to find a postulate or a theorem. Ha 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 ha, theorem 1A. If each of two angles is the supplement of the same angle or equivalent angles, then the two angles are equal. I'm sorry for all the extra noise. My cat has decided he needs to help me record this. Okay, so if two angles are, theorem 1, if two angles are equal, their supplements are equal. Angles equal, then please don't turn off my microphone, cat. Supplements equal. Okay, so again, just like you're going to be looking through your book, I am too. Get as much information into your head as you can. Okay, so now we know that we have very helpful cat. Okay, so we have this green angle here. Because they're opposite angles, they're congruent. We have a side, and now we have I don't need your help drawing angle lines, cat. Okay, so now we've got angle, side, angle. Leave my microphone alone. We know that our triangles are now congruent. So 7, triangle A, back up, AOP is congruent to triangle BOQ. 7 because of angle, side, angle. 8, angle A is equal to angle B. 8 corresponding parts. Okay, so it takes a while. Again, as much information into your head as possible, very helpful. All right, let's look at this next one. Hopefully my cat will try and be less helpful. All right, in diagram POR, I believe this is on page 69 or 68 or something like that. In the diagram, POR and QOS are straight lines. Angles 1 and angles 2 are equal, angles 3 and angles 4 are equal. We need to prove that O is the midpoint of QS and that PR is perpendicular to QS. Okay, so again, there are a couple different ways we can go about this. I'm trying to put my microphone somewhere where the cat is not going to get it. Sorry. try that, maybe? No, I don't. Stop being helpful, Kat. Okay. All right, so what we're looking at, we're concerned with lines QO and SO and the angles at point O. There's 4 angles over there at point O. Go away, Kat. Okay. So we've got these 4 triangles, or 6 triangles, depending on how you look at it. And we know that we've got all sorts of information about angles. We've got all sorts of information that's kind of hiding, but is there, about equivalent lines. Okay, so going with our proof, starting with our given, angle 1 is equal to angle 2. Angle 3 is equal to angle 4. 1 given, 2 given. Okay, so POR, QOS are straight lines. Doesn't really tell us necessarily. We'll write it down. 3 POR equals 180. 3 given. 4 QOS equals 180 given. Okay, so now what we know, we have all sorts of different triangles that we can be looking at. All right, so your book then tells us to look specifically at at triangle, I believe, PQR and triangle PSR for some specific reasons, because we know that we've already got this angle and this angle are equivalent in them, and this angle and that angle. So angle 1 is in triangle PQR, angle 1 and 3 are in PQR, angle 2 and 4 are in triangle PSR. So we've got 2 equivalent angles. Now we just need to, again, if we're going for that side, or for the angle side angle, we just need to prove that side that's in between them is also congruent, and then we have 2 congruent triangles, which, luckily enough for us, that line PR is shared between both of them, so of course it's going to be the same length in both of them. So 5 PR is equal to PR because of the reflexive property. Or postulate or something. Property. Okay, that's a property. Okay, so now we know that that is the same, and so we have 6. We have triangle PQR congruent to triangle PSR because of angle side angle. Yay! Okay, so all right, so now within triangle PQR and within triangle PSR, we have these other lines, which I believe they're called the altitude, the distance from the base of the triangle to the opposite point. Anyway, it's in both triangles, and so therefore they are corresponding parts, and therefore they're the same. It doesn't really matter what they're called. So QO is equal to OS. Oh no, we can't jump there, sorry. Okay, now since we have these equivalent sides, we can use that since these big triangles, sorry, are congruent, we can use that information with these smaller triangles. Okay, so if we break down our triangles into POQ and POS, again, we've got PO is shared with both of them. So now we again need that little bit of extra information, but PQ and PS were corresponding parts of those bigger triangles. So PQ is equal to PS because they're corresponding parts. So now 8, we have triangle POQ is congruent to triangle POS. Because again, they're sharing this side. We've got angles 1 and 2, and then because PQ and PS are equivalent, as we were proving triangle PQR is congruent to PSR, those were corresponding parts. So now we have side angle side on these littler triangles. So A is step 9. QO is equal to SO because they're corresponding parts. Okay. Okay, and so because they're also corresponding parts, we also know that angle Q, or angle QOP is equal to angle SOP because again, they're corresponding parts of those little triangles POQ and POS. Angle QOP is equal to angle SOP, 10 for the same reason. And then 11, okay, so since we had these are straight lines, since we had straight lines and that was given to us up at the beginning, we know that angle QOP, they're equal. Sorry, we're going to write it differently. R is perpendicular to QS because if two intersecting lines are coming in with equivalent angles, again, the supplementary angles have to be 180. If they're equal, that can only mean that they're 90 degrees. So two lines are perpendicular if they intersect at adjacent angles, or at equal adjacent angles. Okay, so that was, again, kind of a bit of a process, but as you go and as you keep working on it, it's going to get faster and faster. Hopefully, we won't have too much feline help in future videos. That will also help the process. Again, let me know if you're not following why we're going from one step to the other. As you can see, this proof was slightly different than the one that was given in your book, but it's still valid.